Well, let's look at these three different measurements here. The one on the left is 8 centimeters. The one on the right is 8.0 centimeters. And the one on the far right is 8.00 centimeters. So obviously the first measurement is only precise out to the ones place. The next one is precise all the way out to the tens place. And the final one is precise all the way out to the hundredths place. So we can see that as we're adding on digits, we're showing that a number is more precise. So more digits indicate a more precise measurement. So let's look here then at a ruler, for example. Let's figure out, okay, so how many significant digits should I record for a particular measurement? Now the rule is that you're going to record all of the known digits plus one final estimated digit. Another way to think of this is you're going to do one final estimated place. So for example, let's say we have this lovely red paper clip here. So we can see that we have the ones place, the ones place, the ones place. These are all ones place. So we know the 2. So the 2 is the ones place. So we can clearly see that. But we have to estimate one more. We got to do a final estimated digit. So in this case, I'm going to estimate, that looks like about 0.3 to me. So I'd write that 2.3 centimeters. But the nice thing is, as I said, that last digit is estimated. So maybe you think it's 2.4 centimeters. That's okay too, because this last digit is estimated. The thing is that we all agreed on the ones place because the ones place was the one that was clearly marked on here. Now on this ruler, we have the ones place marked, but we also have the tenths place marked. So we can see we got 0.1, 0.2, 0.3, 0.4, 0.5, etc. So now, okay, what do I clearly know? Well, I know the 2 for sure, and I know it's 0.3 for sure. But there's a hundredths place that I can estimate. So I'm going to say that looks like about 2.33 centimeters to me. But again, you might say, oh, that's 2.34 or 2.32. That's fine because we all agree on the ones and the tenths, but we're all estimating the hundredths. So again, the rule is you record all of the ones that are clearly marked off of your measurement device plus a final estimated place. So in this case, the ones in the tenths place was clearly marked, so we estimate a hundredths place. And in the first case, the ones place was clearly marked, so we estimated a tenths place. Well, how about then for non-measurement? Maybe you're just given a number and you want to try to figure out how many of those digits are actually significant. Okay, well the first rule says that all the non-zero numbers are significant. So for example, 843. So all of these numbers are significant. So we got 1, 2, 3. So this one has 3 significant digits, or SigFigs. Rule number 2 says that zeros that are between non-zero numbers are significant. So for example, 307. Well, in this case, the 0 here in the middle has been sandwiched in between the 3 and the 7. So this is still 3 significant figures. The 3, the 0, and the 7 are all significant. Now, rule 3, though, says that leading zeros, or zeros that are on the left of a number, are not significant. So for example, I've got 0.0025 here. So leading zeros, or zeros on the left of a number, are never significant. So these zeros here do not actually add anything then to the precision of our measurement. So as we'll see in our lesson on scientific notation, I could actually write that number a completely different way. I could write it 2.5 times 10 to the negative third. So in this case then, you can see that those zeros weren't significant because they don't even show up when I write it in scientific notation. But we'll come back to that though a little more in our lesson on scientific notation. But for now, just know that zeros on the left are not significant. So this is 1, 2. So this has 2 significant figures. And the fourth rule says that trailing zeros, or zeros that come after a number on the right, are not significant unless there's a decimal point. So that's our big caveat here, unless there's a decimal point. So I've written 250 3 different ways here. So the first way, 250. Okay, our rule says that trailing zeros after a number are not significant unless there's a decimal. and this number doesn't have a decimal. So only the 2 and the 5 are significant. So this would have 2 significant figures. So this 0 here apparently was not important. If that 0 had been significant, and we wanted to show that it was exactly 250 instead of around 250, well, then we should have written it like this with a decimal, because that would have been 3 significant figures, because now this 0 at the end is significant because there's a decimal point. Same thing on this one here on the right. Both of these zeros are on the end, or trailing zeros, but they are significant because there's a decimal point. So we'd have 1, 2, 3, 4 because of that decimal point. So this would have 4 significant figures. So again, zeros on the left are never significant. These are just simply what are called placeholder zeros. But zeros on the right are significant if there's a decimal point. So let's just go through a few quick examples and we'll wrap this up. So how about the number 23.5? How many of those digits do you think are significant? Well, they're all non-zero digits, so they should all be significant. So 1, 2, 3. This would have 3 significant digits. How about 23.50? Well, our rule number 4 said that zeros on the end, or what I call trailing zeros, are only significant if there's a decimal. And look, there is a decimal. So this would be 1, 2, 3, 4. This would be 4 significant figures total, or 4 significant digits. How about 402? Well, this 0 has been sandwiched in the middle of 2 non-zero numbers. So all 3 of these would be significant too. This would be 3 sig figs. How about 5200 or 5200? Well, the 5 and the 2 obviously are, but the question is, are these zeros on the end? Well, again, the rule says that zeros on the end are not significant unless there's a decimal, and there's no decimal, so these aren't significant. So we would only count that as 2 significant figures. And again, as I alluded to earlier, in our lesson on scientific notation, we'll see why this is, because this number could have been written another way. We could have written it as 5.2 times 10 to the third, and then we clearly see that these zeros on the end, again, are just placeholders. Now, how about 0.030? Okay, rule number 3 said that zeros on the left are never significant, so those I'm just going to mark out. How about zeros on the right, or trailing zeros? Well, those are significant if there's a decimal. And again, it won't matter where the decimal is. So here's the decimal. So as long as there's a decimal anywhere in the number, then all the trailing zeros, or the zeros after a number, are significant. So this would be 1, 2, or 2 significant figures. Okay, let's do one more and wrap it up. How about 0.0070080? Okay, well, zeros in the front are never significant, so we can not count these. We know these zeros that are sandwiched in the middle of the 7 and the 8 are significant. But how about this 0 on the end? Well, the rule says it is significant if there's a decimal anywhere in the number. Oh, and here it is right here. So yeah, this 0 is significant, so that would be 5 significant figures. Well, I hope you found this brief lesson helpful. For more practice problems with significant digits, please come and visit me at getchemistryhelp.com. Thank you. Well, hello again. Welcome back to getchemistryhelp.com. My name is Dr. Kent, and today I'm going to give you a lesson on significant digits and calculations. Now, specifically, we're going to discuss how to determine how many significant digits an answer should have in a calculation. Well, really, it's going to depend on what kind of calculation are you doing, because we're going to see that the rules for multiplying and dividing are different from the rules for addition and subtraction. So when you multiply and divide, the rule says that the answer is going to be limited by the measurement with the least number of significant digits. Okay, so what does that mean? Well, let's say I have this calculation here. So I take 13.91 meters, I multiply it by 23.3 meters, and that equals 324.103 meters squared. Okay, well, the precision or the significant digits of my answer is limited to whatever the least precise or the least number of significant digits were that went in. So this one, we can see, has 4 sig figs. So this one is precise out to 4 significant digits. This one is precise out to 3 sig figs. So if I put in a number that's precise out to 4, multiply it by 1 precise out to 3, it wouldn't make any sense that my answer over here could suddenly be super precise and have 6 significant digits. No, I'm limited to whatever the least precise number that went in was. So the least precise was 3, so this can only have 3 significant digits. So that's what I had to round it off to. So 324.103 would round off, and I would get 324 meters squared. Good. Okay, let's do one more example with with multiplication and division. So this one, 5.3020 divided by 360. So I went ahead and I punched that in my calculator, and I got 0.0147277, repeating. The units here are grams divided by milliliters, so literally just grams per milliliter. Okay, so multiplication and division, got to figure out what was the fewest number of significant digits. So this one, how many does it have? Well, the 5, the 3, the 0, the 2 definitely are. How about this trailing 0? Well, trailing zeros are if there's a decimal, and there is. So all of these are. So this is 5 significant figures. How about 360? Well, definitely the 3 and the 6. Again, we just said that trailing zeros are if there's a decimal, and there's no decimal here, so that one's not significant. So only the 3 and the 6 are. So this would be 2 significant digits or figures. Okay, so my answer can only be as precise as my least precise measurement that went into it. So obviously the least precise is 2 over here. So this can only go out to 2. Okay, so which 2? Well, leading zeros, we learned in our lesson before on significant digits, are never significant. So the 1 and the 4 are the first 2 that are significant. So we just round them. 7 tells me to round up and add 1 to that 4. So that'll become 0.015, and again, grams per milliliter. Okay, so that's how we do it when we multiply and divide. The fewest sig figs of a measurement determines how many sig figs the answer can have. Now, when we're adding and subtracting, it's a little different. Now, it's the number of places in the answer that determines how you should round off the places in the end. So the number of places in the answer should be rounded to the same number of places as the least precise measurement. And I'm sure that sounds like a bunch of gobbledygook right now. But when I say places, I mean things like the ones place, or the tenths place after a decimal, the hundredths place, those kind of places. So, again, here's an example. 4.1 plus 3.75 gives 7.85. Okay, so what's the least precise measurement out of these two in terms of places? Well, 4.1 is precise out to this place. This is the tenths place. 3.75, okay, that's precise out to this place, which is the hundredths place. Okay, so obviously tenths place is not as precise as hundredths place. So the least precise measurement was the one out to the tenths. So my answer can only be out to the tenths. Or sometimes one way to do this is just to draw a line after that least precise place. So I'm going to draw it right after that tenths place. So 7.85, that would round off, and that would become 7.9 milliliters. Okay, let's do one more example with addition and subtraction. Now this one says 4,970 subtract 342.1. Now, as you notice on this one, it was pretty handy to have these lined up when they're various places. I had the ones lined up, the tenths lined up, the hundredths lined up. So I'm going to do the same thing here. So I'm going to take 4,970, and I'm going to line up under that 342.1, and they all have units of liters. So I punch that on my calculator, and I get 4,627.9 liters. Okay, so we got to look here, and we got to see again what's the fewest places that have significant digits? So this one has significant digits in the thousands, the hundreds, and the tenths. Remember, this is a trailing zero without a decimal, so this is not a significant digit. So in this case, the tens, that's the last place that has a significant digit in it, right? That one's not significant. How about in this number? Well, the hundreds, the tens, the ones, and the tenths. So the tenths place has a significant digit in it. Okay, so what's the least precise? Well, this one only goes out to tens, so I would round it off right after the tens. So 4, 6, 7 tells me to round up, make that a 3. But again, as we saw earlier in our lesson on rounding, I can't turn 4,000 into 400. I have to keep something in this ones place. I'm going to put in a placeholder 0. So that would be down to the tens place, 4,630.